Alright, so welcome back. We got a little bit of a easier video today because it's pretty clear what I'm going to be doing lately with everything being so ridiculous in the United States. I haven't even kind of had a plan the same way I had before for what to even work on. But today we're going to be looking at MPLS traffic engineering for the JNCIE-SP exam, and we're going to be working on the shared risk link group lab offered by Juniper right here at this link. So this is going to be the third video. In the first video we kind of had that problem I was talking about where I didn't really know how to proceed. Second video came up with a good plan, so third video hopefully I can finish the whole thing during this lunch hour. I do have a meeting at 1, so I'll need to keep it tight, but the good news is I've been using this new software that makes recording a lot easier for me. I'm going to adjust the camera a little bit. I think it's a little bit too high. Oh god, I was tripped. Okay, yeah, I think that's a little better. My head's more in the center of the screen now. So let's waste no time and go in and finish up the configuration for shared link risk groups. Oh, shared risk link groups. Alright, so here's my topology. First thing I'm going to do is just make sure everything's up because there was an issue with the license expiring where I can only use half the number of virtual CPUs that I was able to use before. So last video I noticed that what that means directly is that it takes my lab longer to boot up, but so that could potentially mean my cron jobs need to be moved back a little bit, but it looks like there's no problems. So that is really, really good news. Okay, so let's just start with provider edge router 1, and then I've already taken care of all this and wiring it up. That's kind of its own beast, so we've just got the rest of the configuration here. Yeah, so I know I've talked a lot in the past about kind of how uncertain I am in pursuing this test. There is some really good news, and that is that I actually emailed the Juniper asking about the changes they've made to their website, and right now they're doing a trial to see if they can offer the E-level exams remotely. So only their employees can sign up for it now. It looks like you don't have the option to do it in person anymore. Just like the CCIE, I was actually really surprised that they still had that option. But you can certainly go and take it remote. That is their plan. It's just right now they're not allowing people to register because they want to make sure they can administer the exam remotely without any issues. So they're only having internal Juniper employees take the exam at this time. But they did tell me that their plan is to, as soon as possible, have it available for regular test takers, which is good news, and it's no longer as urgent that I pass this exam So therefore, my plan before was to take the exam in September, because if I failed, I'd get another opportunity to take it before the end of the year. But now that I've got a new job, that time schedule can be a bit more flexible. So what I might actually end up doing is taking the exam a bit later. It'll give me more time to study, which I kind of desperately need right now. I'm definitely falling way behind on my study plans. And I'm not planning to do a retake anymore. If I fail, I fail. That's the way I'm planning to approach it. So there's no reason to, so really the best course of action for me right now is to take it for the first time when I had originally intended to take it for the second time. Give me more time to study, and there's no longer the need to give myself some extra time to go back and retake it, because I only plan to take it once. Okay, so we've got a number of options here. We've got loose, loose link, abstract, and strict. We're going to go with strict. That means that the next hop must be adjacent. So another common option is loose. With loose, that requirement is different. You no longer need a next hop to be adjacent. Or that requirement you can make optional by using loose. But one thing that is clear from the description, these are really good descriptions, is that you have the option between making it so that it must be adjacent, making it so that it must not be adjacent, or you can make it so that it can or cannot be adjacent. It doesn't matter. So loose link is the one I would probably typically go with in the real world, so that it's one less gotcha. So this is something I find pretty interesting here. Path 2. I'm not sure, because it looks like that's the name of a path. But I don't see any configuration for path 2. Maybe I just haven't got, oh, I see it, okay. Okay, so this is a secondary path, but there's no to statement, so I guess I'm confused why this is missing something like this here. That might even be something worth submitting a downvote for. We will see at the end of the lab. Okay, so now we've got, so this is what we're learning about here, SRLG. So we set a value, we set a cost. One thing I didn't do is go through and question mark everything out when I did that, so I'm going to do that quick before committing it. So let's do edit routing options, and we'll see what the help says here. It says SRLG configuration. Okay, so let's see what kind of options we have here. We have the option to create a group name, which we already did. So let's see what options are available after creating the group name. So we can do a value or we can do a cost. Those are the only two options you have, and we did both of those things. So let's see if the configuration commits. The other thing I'm noticing with having less CPU cores is that commits look like they take a little bit longer, but not a huge deal because they still don't take that much time. So let's move on to Rudder P1. Looks like everything's good with that configuration. And I do have something in the oven, so I might need to take a quick break to take it out of the oven eventually. Okay, so it looks like this actually looks kind of interesting because I don't remember adding this. I don't remember adding this in the first time around. Let's see if it just snuck by me. Nope, so it looks like this, even though it's defined globally, it's just never applied anywhere. So I'm not sure if that's how it's meant to be, or if there's a problem with that, or if I'm just not seeing it. But I don't see a -A anywhere except for here. So there might be pretty big issues here, but we'll find out at the end. Now this is OSPF, so you're going to need to enable traffic engineering. If it were ISIS, it'd be enabled by default. But if you use OSPF, you don't need to do anything special on the interfaces because OSPF rides on top of family INET IP addressing, whereas ISIS uses its own special family ISO addressing, so you need to enable the ISO protocol on the links, and then you need to set up an address on the loopback address, or sorry, the loopback interface. And it has to be an ISO address. You don't set up an IP address, you set up an ISO address under family ISO. Okay, so that's P1. Let's move on to P2. And I think I'm just going to kind of wait until the end to really verify things carefully. In my older videos, I think for the 960 exam, I pretty much only did exercises, and I just waited until, basically I just did a setup. All my videos were pretty formulaic. They were like tearing down from the last one, setting up the new one, putting in all the configuration and then verification steps. So I had like 3 videos for every topic, and it was pretty clear in every video what the content was going to be. That's quite a bit different from how I am doing it now, but things have just not been consistent enough to have consistency at a high level. So the help is a little bit misleading on that, because it looks like it says configure traffic engineering attributes, but that's really not all that that command does. It enables the traffic engineering feature as well. But for only getting 3 words to use, I think it is totally fine. Okay, so provider router 3 is next. Now I know there is sometimes a bug where it will delete my last commit, but I don't see that bug. Oops, wrist is in a kind of a weird position. Perfect. Okay, so we've got one last section. That's going to be the OSPF section. All right, and now it's time to configure provider 4, assuming this goes through. It is kind of annoying that it takes a little bit longer now. But just the fact that there was a free solution for me is really, I don't have anything to complain about. Oops, we already gave it a value, so now we need to give it a cost of 10. Alright, time for provider router 5. Okay, one more router to go, and then we can move down to the verification steps. In a previous video, while I was waiting for things to happen, I already read through the step-by-step, didn't really see anything interesting, so can kind of just skip that step-by-step. Oh, and I might need to take my thing out of the oven soon, but I'm just going to finish this up first. So we got some extra interfaces on this one because it is a provider edge router. Alright, so now it's time for the verification steps. I think I am going to take a 1 minute break or so to check the thing I have got in the oven. And when I come back, we'll be confirming that the configuration is working properly. Alright, so I am back. My thing turned out perfect from the oven, so that is good news. Let's go ahead and confirm that the configuration is working properly. We'll be verifying the SRLG definitions, verifying the TE-Link SRLG, and then verifying the standby secondary path. I think we'll have some issues here because we can see in the configuration given for PE1, it defines an SRLG group named SRLG-A, but it never calls it anywhere. So that'll be interesting to see that last step of verification, because I think there will be some issues. Okay, so I lost my spot, but luckily you can just click down here. Perfect, okay. So we're going to start on PE1, and we're going to look at the SRLG group that we defined and named SRLG-A. And hopefully we'll see a value and a cost. Yep. Okay, next step is to verify the TE-Link SRLG. So we should have two of them here. Looks like we've got a ... so there might be more than just these two, but these are the ones that are important. So if there are more, we can filter them down. Yep, so there are plenty more, so let's find a way to... Well, it looks like there's not that many, so the first one we're gonna look at is 10.255.0.2. Aha, so I see it right here. And then it's going to be going to .27.2. Oh, so that looks different. This one is going to .27.7. Okay, so it looks like I am missing a TED link. So let's try to figure out where in the network this 27.7 is meant to be. So let's just see if I can ping that address. And it looks like I can, so let's do a tracer out and try to find out where this is in the network. Okay, so it looks like it's going to be 2 hops away. So let's look at our topology. And so it's not going to be any of these. It's not going to be this one because this is 3 hops away. So it's either going to be PE2 or PE4. Or sorry, P4. Okay, so let's do a show route and see if there's a directly connected route on either of these. So this is learned from OSPF, so it's not going to be on there. And here we go. So this is kind of what I expected because we didn't have the same kind of configuration on PE1 as we were given for PE2. You can see on PE2, oh, well, never mind. They do look pretty similar. Okay, well, this is 001, so let's just verify that it's added to OSPF. Yep, that looks good. Okay, let's just verify the whole config. We'll do a show configuration pipe display set, pipe match on that interface. Yep, so it looks good. I mean, it might just be a little different. It is the lab versus the lab I'm using versus the lab they're using, so there could be little differences. But you can see very clearly we don't have the kind of output they were expecting. Let's see if the second one will show up. Same thing. So, I mean, this kind of makes more sense to me because you can see, well, this doesn't make any sense to me. Well, let's focus on one that I think does make sense. So I think this one makes a lot of sense here, because if I do a show route on this address, oops. Yeah, I mean, this is really good because I've never looked at this command before. This is my first time. I don't understand everything that's coming up. I think it could be normal still, that it looks this way here, but different on mine because they're different labs. They might make different calculations. So let's just move on. But this is something I'm definitely going to need to check my learning on by the time I'm done with this, because it's all new to me, and it's really not clicking right now. So let's move on. Hopefully that will become more clear later. So we're going to verify the standby secondary path. We're going to check the SRLG link cost and its impact on the CSPF computation of the standby secondary path link. So here we got a big, so this is a big reason why that wasn't showing up. It looks like we've got the LSP here in state down. Definitely going to need that in state up. This is the only LSP they're concerned about. So let's see if, yep, this is the only one here. So we've got to figure out why. Aha! So it failed because there's no route toward that. So let's start off, see if I can ping it. So perfect, of course, I can't. No route to host. So I'm thinking that this address is missing. Let's do a show route here and so perfect. You can see I configured all of the physical interfaces, but I forgot to configure the loopback interface. All I did in terms of configuration applying to the loopback interface is added it to protocols OSPF, but I did not set it up with family INET. I think it's also going to, no, I think that's all it's going to need. It doesn't need family MPLS or anything like that, but I could be wrong. I just hope I'm right so that I have a better understanding of this. So I am right. Perfect, okay. Yeah, I really think I'm starting to get it. it's a lot, but it's I've been studying a lot. That's kind of my hope with having it all public on YouTube like that, is I can, before test day, go back and kind of have some more confidence because it's all out there. Yes, I legitimately did study at least an hour a day, sometimes 2 or more hours a day for this exam, which isn't true now because I've been skipping the weekends, but once they have the actual registration open, and I know for sure that I can actually take the exam, I'll probably be ramping up my studying a bit more. But the really good news is I'm going to have about 2 or 3 extra months to study than I had originally thought I would. Okay, so let's go back to the first step. Now that I've corrected that mistake, and let's see if the TED, Traffic Engineering Database, shows information for that new link. Before we do that, let's see if we've got the route to the host yet. Okay, perfect. So now let's see if it shows up the way they're expecting it to. And hopefully I can narrow it down. Now. So we've got a lot more now that there's a whole new connection. So this one's from .7. We're going to look for one from .2. Okay, here's one from .2. Perfect. So now that I set that one up to .7, now we can get one to .27.7 from .0.2. So that's kind of interesting that even though I was missing configuration for an address that was not a part of this TED link, I couldn't have that DET link without that configuration that is seemingly unrelated. So it looks like local path is different. I've got 0 for that. They've got 1. We've got the same metric. We've got the same bandwidth. We've got the same available bandwidth. Same local remote interface index. Same remote, same local. Yeah, everything else is the same. So the only thing that's different is they have local path 1 and I have local path 0. Let's check the next one, which is .3 to .37.7. Okay, so it's this one here. So this is interesting because it looks like I have local path 1 for this one, but they have local path 0. So they're kind of flipped. I almost wonder if, nope, I am on PE1. I wondered if I was on PE2 or something. But nope, looks like it's good to go. Okay, so let's move down to the next one. Okay, so so now it is up. That's a huge difference. Having it be down was definitely throwing a wrench in the plans. Check the standby secondary path. The effective link cost for PE2 through P2 to provider edge 2 is 11, with the added SRLG cost of 10. Okay, so let's verify that it is 11. I have a feeling it won't be 11 because we defined it, but we never called it. So I'm going to be looking for Aha, so the CSPF metric, I believe. That's at 2 right now. I think that needs to be at 11. Let's see what it is. Oh, no, it is at 2. So this is something else besides the CSPF metric. Now, one thing that is interesting is if this is meant to look at the backup path, something is wrong here, because this is the ingress LSP is going to be the is not going to be the backup path. It's going to be the primary path. Okay, I don't see anything like cost just looking it over, so I'm gonna make it easy on myself and do a search for it. Oh, and I don't see anything like that there, so let's see if 11 shows up. Don't see anything like that there either. Now, one thing I did see is SRLG did pop up. You can see that right here. It looks like it's the primary here as well. So I'm not sure where they see that the effective link cost is 11. So it looks like here's another example. It looks like it's just a modification of the first example. These preceding examples are just modifications. Is preceding the right word to use there? I'm gonna look it up. Coming before. Oh, well, that is not the right word. I thought there was something wrong there. But these next examples here are just variations to the preceding examples. Okay, so I think I'll do that. So let's go back to the first example here and down to the verification. And yes, the verification is all finished, so we'll do the next example here. For critical links where it is imperative to keep the secondary and primary paths completely disjoint from any common SRLG, you can optionally configure the exclude SRLG statement at the edit protocols MPLS or edit protocols MPLS label switch path name hierarchy levels. For logical systems, you configure the exclude SRLG statement at the edit logical systems protocols MPLS, edit logical system name protocols MPLS label switch path name hierarchy level. If exclude SRLG is configured, the constrained shortest path first CSPF algorithm excludes any link belonging to the set of SRLGs in the primary path. If exclude SRLG is not configured, and if a link belongs to the set of SRLGs in the primary path, CSPF adds the SRLG cost to the metric but still accepts the link for computing the path. In this example, PE1 is the ingress router and PE2 is the egress router. P1, P2, and P3, P4, and P5 are transit routers. OSPF is configured on all the routers as the Interior Gateway Protocol, IGP. SRLP is configured on all 7 routers. The primary path includes SRLG, SRLG-A. For the standby secondary path, the link P to PE2 belongs to SRLG, SRLG-A. Because exclude SRLG is configured, JNCIE-SPF rejects link P2 to PE2 as the link belongs to the SRLG-A. Therefore, the computed standby secondary path is, and let's point it out, PE1 to PE3, provider edge 1 to provider 3 to provider 4 to provider 5 to provider 2. So we're going to change the secondary path in this next one by changing the links that the SRLG is associated with. Okay, so basically we're just going to disable SRLG from MPLS. So it looks like all we need to do, so yeah, let's go through this step by step. So the first step is to configure the interfaces, did that already. Second step is to configure OSPF, did that. SRLG definitions, done. So now it looks like we've got some things that are different here. So let's add those changes. Okay, so first change I see. So optimized timer is not a change, that was already there. That kind of took me by surprise. So periodical path re-optimizations. Okay, well that's interesting. I wonder if that's got to be balanced with anything. I'm going to do a quick help apropos on that, just to see if there's any gotchas or caveats associated with that. Looks like help apropos might take a little longer with the fewer CPUs as well. Okay, so let's see if there's any good documentation for MPLS. Once an LSP has been established, topology or resources changes might, over time, make the Once an LSP has been established, topology or resources changes might, over time, make the path suboptimal. A new path might have become available that is less congested, has a lower metric, and traverses fewer hops. You can configure the router to recompute paths periodically to determine whether a more optimal path has become available. If re-optimization is enabled, an LSP can be rerouted through different paths by constrained path recomputations. However, if re-optimization is disabled, the LSP has a fixed path and cannot take advantage of newly available network resources. The LSP is fixed until the next topology change breaks the LSP and forces a recomputation. Re-optimization is not related to failover. A new path is always computed when topology failures occur that disrupt an established path. Because of the potential system overhead involved, you need to control carefully the frequency of re-optimization. Network stability might suffer when re-optimization is enabled. By default, the optimized timer statement is set to 0. That is, it is disabled. Oh, that's interesting. So you don't get this optimization unless you enable it. I always thought that the LSP would kind of do this by default, but it does not. Configuring LSP optimization is meaningful only when constrained path LSP computation is enabled. That's good to know too, which is the default behavior. For more information about constrained path LSP computation, or CSPF, see disabling constrained path LSP computation. To enable path re-optimization, include the optimized timer statements. for a list of hierarchy levels, blah, blah, blah. Once you have configured the optimized timer statement, the optimization timer continues its countdown to the configured value, even if you delete the optimized timer statement from the configuration. The next optimization uses the new value. You can force the Juno software to use a new value immediately by deleting the old value, committing the configuration, and configuring the new value for the optimized timer statement, and then committing the configuration again. After re-optimization is run, the result is accepted only if it meets the following criteria. Okay, so this is obviously a really good you know what I'm gonna do? I've got 6 minutes left. I'm just gonna finish reading this, and then that's gonna be the end of the video. I'm going to save my place. So right here. Oops. Okay, so I saved my place. So now I'm going to add this to here, and this is going to be the third video, and the fourth video will continue through the rest of those examples. But for now, I've got 5 minutes, so I'm just going to finish reading this. After re-optimization is run, the result is accepted only if it meets the following criteria. Number 1, the new path is not higher in IGP metric. The metric for the old path is updated during computation. So if a recent link metric changed somewhere along the old path, it is accounted for. Number 2, if the new path has the same IGP metric, it is not more hops away. Number 3, the new path does not cause preemption. This is to reduce the ripple effect of preemption causing more preemption. Number 4, the new path does not worsen congestion overall. The relative congestion of the new path is determined as follows. A, the percentage of available bandwidth on each link traversed by the new path is compared to that for the old path, starting from the most congested links, such as my throat. Okay, so I did a re-optimization on that by enabling the optimized timer command on my throat by drinking a glass of water. So let's continue on. B, for each current old path, the software stores the 4 smallest values for bandwidth availability for the links traversed in ascending order. C, the software also stores the 4 smallest bandwidth availability values for the new path, corresponding to the links traversed in ascending order. D, if any of the 4 new available bandwidth values are smaller than any of the corresponding old bandwidth availability values, the new path has at least one link that is more congested than the link used by the old path. Because using the link would cause more congestion, traffic is not switched to this new path. E, if none of the 4 new available bandwidth values is smaller than the corresponding old bandwidth availability values, the new path is less congested than the old path. When all of the above conditions are met, then number 5. If the new path has a lower IGP metric, it is accepted. Number 6, if the new path has an equal IGP metric and lower hop count, it is accepted. Number 7, if you choose least fill as a load balancing algorithm, and if the new path reduces congestion by at least 10% aggregated over all links it traversed, it is accepted. For random or most fill algorithms, this rule does not apply. Number 8, otherwise the new path is rejected. You can disable the following re-optimization criteria, a subset of the criteria listed previously. If the new path has the same IGP metric, it is not more hops away, that can be disabled. The new path does not cause preemption. This is to reduce the ripple effect of preemption causing more preemption. That rule can be disabled. If the new path does not worsen congestion overall, I don't know why you would disable that, but you have the option to. If the new path has an equal IGP metric and lower hop count, it is accepted. That can be disabled as well. To disable them, either issue the clear MPLS optimize aggressive command or include the optimize aggressive statement. You can include this statement at the following hierarchy levels, including the optimize aggressive statement in the configuration causes the re-optimization procedure to be triggered more often. Paths are rerouted more frequently. It also limits the re-optimization algorithm to the IGP metric only. Alright, so that's it for this video. Next video we'll be doing the rest of the examples. So thanks for watching, and I'll see you in the next one.